Hello student, here I am starting from the last video. We are continuing the time series analysis video. So here you can see the joint PDF of the time series or probability density function of the time series. To be able to identify the structure of the series, we need the joint probability density function of y1, y2 and y1. However, here y1, y2 till yn are different time series values at different times or might be at different time point. So however, we have only one sample, means only one observation of or only one variable observation, that is one observation from each random variable. Therefore it is very difficult to identify the joint distributions, hence we need an assumption to simplify our problem. This simplifying assumption is known as stationarity. The most vital and common assumption in the time series analysis, that is stationarity. We need to go for stationarity assumption. The basic idea of stationarity is that the probability laws governing the process do not change with time. So here you need to understand this basic idea of stationarity is the probability laws. The probability laws governing the process do not change with time. The process is in statistical equilibrium. So you need to assume that the process of getting the samples from one random variables or more than one random values from one variable will be in statistical equilibrium, and it will not change with time. The probability laws governing the process will not change with time. It will be in a equilibrium state. So which is the stationarity assumption in case of time series, and this is most vital and common assumption in case of time series analysis. So here you can see types of stationary are like that: strict, strong or complete stationary process. Consider a finite set of random variables such as yt1. So consider a finite set of random variables such as y1, yt2 and ytn from a stochastic process. Suppose ywt t equal to 0 or plus minus 1 or plus minus 2, like that. The n-dimensional distribution function is defined by distribution function of n dimension because there is n number of random variables in that stochastic process. So function of yt1, yt2, yn should be encompasses with that yt1, yt2. So functions of all these variables will be included in the probability distribution, n-dimensional distribution, where w value of yt will be less than equal to y1, small y1, and like that yt2 will be less than equal to small y1, where yi or y1 are any real numbers. So what this is giving it is like that the values of this yt1 or yt2 will be less than or equal to any real numbers. So that is the strong or strict stationary process, because those random variable will be in the range of any real number. A process is said to be first order stationary in distribution if its one-dimensional distribution function is time invariant. That is, suppose any value of yt1 uh, for any time t1 and k, means t1 plus k of y1 will be equal to yt1 of these functions will be similar, means previous values will be similar with the future values, means the function will be similar. How they are changing means whatever value you will get applying the y1 in this function will get, which will be similar to the y1 for the next point. Second order stationarity in distribution if you go for two values y and y2 with two different random values yt1, yt2, which will be similar. The function will be similar with two other values of y2, y1 and y2 for next t1 plus k or t2 plus k of that random variables yt1 and yt2 for any t1 and t2 and k, and order stationary in distribution if the same value applied like this. So and order stationary in distribution equal to strong stationary, mean how many order we can get, that will define the stationarity value of the distribution. Shifting the time origin by an amount has no effect on the joint distribution, which must therefore depend only on time intervals between t1, t2 to tn and not on absolute time t. So here you can see, so for a strong stationary process, you will follow this equation because this is getting from this one, and order stationary. So this will follow this one. So expectation of yt, expected value of series is constant over time, not a function of time, equal to e of yt plus k, where mean of t, mean of this t will be almost similar to mean of this one, or you can say mu for all t and k. Variance of yt will be variance of t plus k, where sigma square t equal to sigma square t plus k. Then sigma square will be the variance will be similar throughout the series. The variance of the series is constant over time, or we can say homoscedastic or covariance. Covariance here you can see not constant, not dependent on time, depends on the time interval, which we call lag. So that is the point of mathematically we can say this equation, but theoretically we can say that lag value, or if the two values, if these two time series for different time points have, if they have some lagging, that will be constant over time, because that will depends upon only the time interval, which might not be constant or might not depend upon time, but that it will depend upon the time interval, which we call lag. So that variation, covariation or covariance will follow a lagging, that is k. So here you can see in this one, suppose y1, y2, y3. So for y1 there will be suppose mu and sigma square for everyone, and for y1 will be also mu and sigma square. Every value will follow the same mu value, means so same mean and same standard deviation or variance. So covariance of this y2 and y1 will be y gamma of -2 minus 1 gamma 1 effective from time lag 1. So suppose any two interval y3 or y2 or y1, so it will vary, but that will be affected by simple constant. But here you can see, if we take two different, suppose here we can take y2 and y1, then covariance will be gamma 1, but if we take gamma y3 and y1, then it will be gamma 2. So but if we take two interval, means two 1 and y3, that is difference is 2 interval, and in that way that is a lagging, means if we take three variables, that will be three variable lag or three time interval lagging, so affected from time lag k. So k might be 1, k might be 2, or k might be 3. So that depends upon, that covariance depends upon that time lag or that time interval. Or correlations will be, it is usually possible to verify a distribution, particularly a joint distribution function, from an observed time series. So we use weaker sense of stationarity. So what is weak stationarity? Weak stationarity in wide sense. A time series is said to be covariant stationary if its first and second order movements are unaffected by a sense of time origin. That is, we have constant mean and variance with covariance and correlation beings functions of the time difference only. So constant mean, there will be constant mean and constant variance with the covariance and the correlation, which are the function of the time difference only. So which scenario is that if expectation of yt is mu for all t, and again variance of yt is sigma square for which is less than infinity, and for all t, and also covariance of any two interval is gamma k for all t, correlations of yt and yt minus k, that is pk, is for all t. For now on day, when we say stationarity, we imply weak stationarity. For example, consider time series yt where yt equal to et, and et, that is 0 to sigma, or that is the variance. Is process stationary? Moving apart, suppose at yt is constructed as yt equal to et plus et minus 1 by 2, that is et is between 0 and variance. Is the process yt stationary? Again, another example, that is random one. Yt equal to u1 plus e2 plus et, where et, that is 0 to sigma variance, that is the process yt stationary. So try to think about these examples, okay, and also go through these contents again. It might be a bit tough to understand, okay, but I'll try to again bring more slides from the books, also from some contents, to understand these things about time series analysis, and try to go for more easy topics. But this is actually mathematical oriented. You need to know, you need not to go for more deep here, but try to just understand basic things about time series analysis, and also go through the literature. Also try to read some papers and research papers, and try to understand more about these things, because I am following some slides only, so most of the things might not be in very descriptive way, so it might be not be more understandable to you, or I may not be exactly saying or conveying exact topics or theoretical explanation through these slides, but I'll try to bring some more ideas and applications or techniques through the time series analysis from the books, or might be from other sources. So till then, if you have any confusions or if you have any doubts, please let me know, or if you want to add something, if you want to share something, then also let me know. We'll try to resolve those things over Google Meet. So till then, we'll come till next video. Thank you.